Let's get started. This is GCE 2023 paper 1 physics. We have a question C1. Figure C1.1 shows a velocity time graph of a car of mass 1200 kg, that is 1200 kg. That is a mass, and this is a velocity time graph. So we're going to go step by step on how we can dismantle such questions. Please pay extra attention. So we have velocity time graph. That's the first thing that you should be able to identify. Okay, so they're saying calculate the acceleration of the car in the first 2 seconds. So what is the first 2 seconds? It's from 0 here up to 2. So how do I handle such questions? So come here so that we see how we can handle these questions. So the first thing that we should do is to define the data, bring down the data. So on the data, what is there? So we have the time. So we've been given the time. This is 2 seconds because they're saying calculate the acceleration of the car in the first 2 seconds. So the 2 seconds is the time. What else do we have? So we have initial velocity as well as final velocity. So the initial velocity here is represented by letter U, and then we also have the final velocity, which is represented by letter V. So in this case, we have the initial velocity 0 meters per second, and then the final velocity, which is 30 meters per second. So this is the data. So we have collected the data, and then A here simply means the acceleration that we are looking for. Okay, so after collecting the data, okay, we go to the formula. This is a simple formula that you use for calculating acceleration. So this formula has given us a provision for final velocity, initial velocity, as well as time and acceleration. So let's just impute or substitute what we have in the data. So let's now find the answer. So this is what we are having. So we're saying acceleration is equals to final velocity. What is the final velocity? This is 30. Okay, and then we subtract initial velocity, which is 0, and then you divide time, which is 2. Okay, so this is how we handle these questions. So 30, and then you divide, you're going to have 15 meters per second squared. So this is how you can calculate acceleration using the velocity time graph. Okay, let's go to the second question. Saying B, explain why the acceleration is 0 meters per second squared between 2 seconds and 4 seconds. So if you look at this position here, we are having a constant velocity of the car. So they're asking us a question: can you explain why acceleration is 0 between this point, between 2 and 4? So how do we do that? We can go direct to just putting down the answer. As you can see, the mark is just 1. You can say because velocity was 0, or you can also show your working by just doing some simple calculations. Okay, how do you do that? Let's come to data here. So the time is 2 seconds. Why time is 2 seconds? Is because they're saying why the car is the acceleration is constant between 2 and 4. So if you subtract 2 from 4, you're going to have 2. That is the time. So the time, we have 2 seconds. And then let's find the initial velocity. The initial velocity here is this one, which is 30 meters per second. So we have put the 30 meters per second as the initial velocity, and the final velocity here is 30 meters per second because the velocity is constant. Therefore, the velocity is not changing. Okay, so it's constant. Yeah, so that is what we've put down there. And then we want to calculate for acceleration. Let's now calculate for acceleration so we can prove why acceleration is not changing. So we go to the formula. Okay, so what do we have for on the final velocity? We have 30. What do we have on the initial velocity? We also have 30. And then what do you have on t? That is time, which is 2. So 30 minus 30 is going to give us 0 over 2. If you divide 2 into 0, you're going to have 0 meters per second squared. That is why we are having 0 meters per second squared as acceleration. So when the velocity is not changing, in conclusion, acceleration is not changing, it is 0. Okay, so yeah, hope it's making sense. Let's go to C. So C, the saying calculates the displacement of the car while its velocity was increasing. So at what time was the velocity increasing? Okay, it was increasing from here up to there. So they're asking you to calculate the displacement for the car during this time. Okay, how do you do that? Let's come here. So we're saying we're going to use area under the graph. So identify the shape that has been formed here. Do not go, I've seen most of the students, they go for speed is equals to distance, or velocity is equals to distance over time. No. If you are given a graph and then you are asked to calculate for displacement or distance, look for the shape that you have been given, and then look for the area that you use to the formula that you use to find the area for that shape. In this case, this is a triangle, and we know the formula for calculating the area of a triangle. It is very simple. It's just area is equals to half base times height. Okay, so we have half here. Do we have the base? Yes, the base is here. It is from 0 to 2. So this is the base. So the base is 0, 1, 2. So the base is 2. Do you have the height? Yes, the height is here up to the final velocity. This is the height. So it's from 0 here up to 30 meters per second. Okay, so that is the height. So impute that into the formula, and then you are going to have something like that. So here I can divide 2 and 2, and then I multiply 1 by 30, which is going to give me 30 meters, since it is displacement. Okay, simple as that. So let's go to D. Okay, calculate the resultant force on this car during acceleration. So when did acceleration take place? The acceleration took place from here up to there. Okay, so they want you to calculate the resultant force during this time. Okay, what do we have here? One, we have the acceleration. We calculated for acceleration. Okay, in the first place, that was the first question. So you come to data here and then put down your acceleration. So the acceleration was 15 meters per second squared. Okay, what else do we have? We have the mass. From the introduction of the question here on top, you realize that you are given mass, a car of mass 1200 kg. So you put down that as mass. Okay, here, and then you are asked to calculate for resultant force. So we know that resultant force, okay, resultant force is equals to ma. So you can use this formula from Newton's second law of motion. Okay, so we're saying F is equal to m. Do you have m? Yes, it's 200 multiplied by, do you have acceleration? Yes, that is 15. And then you just use your calculator to find the answer. So multiply 1200 multiplied by 15, and then you are going to have your answer. The answer is going to be in newtons. So let me know how much you have found there after doing your computation. Thank you very much for watching. So we have another question here. Okay, so let's look at it. Okay, distinguish between speed and velocity. Okay, so we know the difference between speed and velocity. So speed is simply the rate of change of distance with time, and then velocity is speed in a specific direction, or you can also say the rate of change of displacement with time, as simple as that. So I don't want to waste a lot of time. So we also have calculated displacement of the car for the war journey. So when you look at this journey, ladies and gentlemen, we have different types of shapes that have been formed. Earlier on, we learned from question C, that if you are asked to calculate the displacement, you just have to focus on the shape that has been formed and then find the area for that shape, and then that is the displacement. For example, we had found the displacement for this one using the formula half BH. So we can also focus on this one. This is a rectangle. We know the formula for calculating the area of a rectangle. It is just LB. Okay, so what is the L? So it can either be this one. Okay, so from here to there, that is 2 steps. So you put your 2 there multiplied by, okay, the 30 from here to there. Okay, so that is the 60 meters. Okay, that is 60 meters. Okay, and then you go to this other one, this shape. This is also a triangle. You can find the displacement for that triangle by using the formula for finding the area of a triangle, half BH. Okay, half, how much is B? Is from 4 to 8, that is 4. So we're just subtracting the smaller one from the bigger one. So 8 minus 4, that is 4. So we're saying 4. And then height is obviously 30, and then you can divide that. So we're having 2 there, and then this is 60. So you're going to add 60. This is meters. Okay, are we correct? Okay, yeah, we're right. So we're going to say, therefore, okay, displacement for the whole journey, we're going to start with the displacement that we calculated here. How much was that? It was 30. So we're going to say 30 plus the displacement that we had calculated here. How was that? How much was that? 60 plus the displacement that we had calculated there, which was also 60. And then when you add all of them, you're going to have 150 meters as displacement. Okay, so that is how you handle such questions. Thank you very much for watching.